This is just putting together the ideas we have discussed in pieces. The intensity is one of the key parameters that everybody wants to know about. If there is a forecast of a cyclone, they definitely want to inquire how intense it's going to be so that they can decide on evacuations, boarding up the houses, and whatever else that the warnings and advisories talk about. People have a sense of how much damage to expect and how to take shelter when they know the intensity of the cyclone. And we will look basically at the key stages of a typical tropical cyclone life cycle. And this is something I took from the Encyclopedia Britannica, which has got a nice schematic here. So days 1 to 5, there is a tropical disturbance, let's say based on the easterly jet, the easterly waves, the MCSs and other things we have been talking about, and it has survived the SAL, Saharan air, and we have the trade winds and the vertical shear, etc., playing their role. But once the incipient vortex has been set up as the tropical disturbance on days 5 to 6, there is a tropical depression that has already got a incipient vortex that has not well organized yet, but it is taking shape. You can see that it's not perfectly symmetric. By the time it becomes a tropical storm, it's got a nice structure already with this counterclockwise rotation. The bands, the eye, and so on are well formed, not always so well formed, but nonetheless a tropical storm is uniformly defined with speeds of greater than 17 meters per second. And days 10 to 15, tropical cyclone is a hurricane already, and you can see that it is now much more larger in scale with stronger circulation that is feeding the core eye and the eye wall and so on, and then it makes some landfall, maybe comes back out or whatever, and then transitions into a extratropical storm. And then you can see the cold core and the asymmetric form that you expect from a typical extratropical cyclone. Obviously not all these stages happen for each cyclone, depends on many factors as we have already seen, but keeping that in mind, and keeping in mind that the cyclogenesis does require incipient vortex, the rotation, vorticity, moisture loading, weak vertical shear, although these days vertical shear is being looked at more carefully because there are situations where vertical shear, the tilting of the vortex, can actually intensify the cyclone or the vortex. So the ideas about vertical shear may be changing a little bit. And of course we need energy from the ocean and vertical motions that are feeding the convection that are trying to strengthen the incipient vortex. So starting with what is called here as tropical Invest 96L, which is Invest is a weather system that's being watched. So the incipient disturbance here, looking at combined infrared and SSMI satellite image for tropical Invest 96L, the disturbance that became Hurricane Rita in 2005, one of the monster record cyclone year for the US in terms of landfalls, that included Katrina, the infamous Katrina that I mentioned. Images are taken near 00 UTC 18 September 2005. Note the hook of the intense convection near the western edge of the image. The peak surface winds associated with disturbance were estimated to be 12 meters per second with minimum surface pressure of 10-12 HPA. So there is a low pressure around which the disturbance is organizing convection. So it is being watched, and it obviously combining multiple satellites to get a good sense. I think this is something sensor microwave imager. You can look it up. I used to remember, I forgot. The next step of a cyclone evolution is that it becomes a tropical storm, by which time it has a nice structure that is well organized and vortex stability at the lower level is now fairly significant to withstand the perturbations from the environment, and the rain bands are beginning to appear. I keep pointing this way, but actually the circulation is counterclockwise, as you remember. Combined infrared and SSMI satellite images again of tropical storm Rita. It's already been named. The Invest 96L has become tropical storm Rita. Again on 20th September 2005, when Rita had central pressure of 993 hectopascal, so dropped significantly, and peak winds of 30 meter per second, well above the threshold for calling it a tropical storm. Based on all the conditions we talked about and the energy from the ocean here, it's already in the Gulf of Mexico, which has very warm waters, which are very conducive to providing the hurricane potential for a tropical cyclone. And combined infrared SSMI satellite images show here again on 21st September Rita with peak winds of 45 meter per second and central pressure dropping to 967 hectopascal, already category 2 on the Saffir-Simpson scale. The intense eye wall and convection are now very clearly seen, so you can see the feeder bands spiraling into the eye wall, and the hurricane is now well formed and off on its way. Not all of the cyclones reach severe tropical cyclones or super typhoons. Major hurricanes in an Indian Ocean, they tend to be called extremely severe and super cyclones based on a slightly different scale, but the peak wind speeds are over 220 kilometers per hour and so on. So now the structure is incredibly well defined. The eye is strong enough and tight enough that you can imagine the intensity here. So combined infrared and SSMI satellite images of Hurricane Rita on 22nd September and 12 hours later here. Now Rita was category 5 hurricane, which is obviously a severe tropical cyclone with peak surface winds of 75 meter per second, minimum central pressure around 898 hectopascal, really low pressure in the eye. In the left panel, note that the clear eye and symmetry of the storm, intense eye wall convection, spiral rain bands, green and red with subsidence between the right and dark blue are seen here in the right panel. Okay, so we talked about this primary flux of momentum into the cyclone and the secondary secondary circulations that happen. So between the rain bands you get this strong ascent in the rain wall, and then you get subsidence in between. So those are the spiral rain bands. Okay. There is of course debate about whether typhoons like Haiyan, I think in 2011, and then there have been others, became much stronger than they would otherwise because of the global warming and the associated moisture loading and so on. That debate will continue. As I said, we will return to that later on. But these are kind of the life cycle steps. So the definitions wise, super typhoon is a term utilized by the U.S. Joint Typhoon Warning Center for typhoons that reach maximum sustained 1-minute surface winds of at least 65 meter per second. That's 150 miles per hour. US keeps doing these units that nobody uses anymore, but nonetheless, this is the equivalent of a strong Saffir-Simpson category 4 or 5 hurricane in the Atlantic, or a category 5 severe tropical cyclone in the Australian basis. Unfortunately, the categories are slightly different in different oceans, but nonetheless, a major hurricane is a term utilized by the National Hurricane Center for hurricanes that reach maximum winds sustained 1-minute surface winds of at least 50 meter per second. This is 65 meter per second. This is equivalent of category 3, 4, and 5 on the Saffir-Simpson scale. So people have gotten used to what is called super typhoon, super cyclone, or major hurricane based on the region they are in. Intense hurricane is an unofficial term but is often used in the scientific literature. It's the same as major hurricane. So media tends to use terms like Cyclone Yash, which didn't actually become super cyclone, but even before it had intensified from a depression or a deep depression into a tropical cyclone. Media was referring to it as super cyclone for whatever reason. Okay, so obviously there is a colloquial terminology that gets used versus scientific terminologies which have specific thresholds associated with them. So the incipient vortex and the disturbance and so on, that the terminology is being used here, like the incipient disturbance, they are called depression and deep depression in the North Indian Ocean based on their identification. Here they are called, for example, invest, whereas they could be called depression by that time. That is, it is formed. Okay, so that's a quick run through the various stages of a cyclone and how intensity increases over time based on favorable conditions. Not all of them go through systematically the same typology, but they all have, once they reach once they are named and reach certain categories, they have specifically defined thresholds of speeds, and then they when they hit land, obviously they break off into pieces, as we saw before, churning of tornadoes, storm surges, and thunderstorms, and so on and so forth.